Hello, wonderful people. Here we are. Today is chapter 34, electric current. We are going to just cover the basics of Ohm's law. It's going to go by a little quick because it's just a simple formula, really. And the hard part is not the formula. The hard part is keeping together the concepts that explain the formula. What is voltage? What is current? What is resistance? So we're just going to explain the just Ohm's law today, and then we're going to practice with it with some homework problems, and we'll do that over the next couple of days. And we'll go a little bit more talking about electricity, but really, Ohm's law is the point of all electricity. In the real world, 95% of what people 99% of what ordinary people deal with when they have to deal with something electrical. It's just a matter of figuring out Ohm's law and understanding what the situation is telling you. Okay, so that's that. Here we go. And here we are, the point of it all. Ohm's law. Current equals voltage divided by resistance. So, that's called Ohm's law, the relationship between voltage, current, and resistance. So how much current you get depends on how much voltage. More voltage means it's pushing harder, and if it's going through a certain resistance, then that's what resists the push from the voltage. And if there's a lot of resistance, you get less current. If there's a little resistance, you get more current. That's what we're going to practice for the next couple days in the homeworks. Okay, so that's Ohm's law. Current equals voltage divided by resistance. So let's get into some of the particulars. Can we abbreviate this? Yes. We're physicists. We abbreviate everything. Now, the obvious thing you would think is to go from just the letters, CVR, current equals voltage divided by resistance. Well, there's a problem with that. 200 years ago, they didn't call it current, they called it intensity. So we abbreviate current with an I, and that's just stuck with us. So you just have to learn that one. 200 years ago, they didn't call it voltage, they called it electromotive force. So they abbreviate V with an E. Now, so that's how Ohm's law is written in the textbooks. Current I equals E divided by R. Now, over the last 100 years, though, we've been calling it voltage instead of EMF. And so about half the time people use V and half the time people use E. Sorry, I wish they would pick one and stick with it, but they don't. But using a capital I for current, however, is here to stay. So I will always give you the equation, but I'll tell you this little triangle. So if E equals, or here it is, current, I equals E divided by R. So if you want to solve for the I, you put your thumb over the I and block that out, and then you have voltage over resistance, E over R. If you want to solve for the R, you put V divided by I, E divided by I. And if you want to solve for the E, you put your thumb over the voltage, and then it's I times R. That's a nice little way of remembering it, but I will always give you the equation. So Ohm's law defines the relationship between voltage, current, and resistance. These basic electrical units apply to direct current or alternating current. We haven't even talked about that yet. Any current. Sorry, skip that sentence. Ohm's law is the foundation of electronics and electricity. That is the truth. Voltage is measured in volts, so there's a unit for voltage. The units are volts. Volts are symbolized with a V. Current is measured in amps, and current is symbolized with the letter I. Oh, I'm sorry, that's voltage is symbolized by the letter E or V. Resistance measured in ohms is symbolized by the letter R. Now, there's the amp, volt, and ohm. Those are the units, and this is what they're abbreviated by. So an amp, which is how current is measured. We've talked about that before. It's 1 coulomb per second. 1 coulomb of charge flowing by in 1 second is 1 amp. Then there's volts, are only abbreviated with a V, V for volts. So volt is the unit, but voltage is the quantity. Similarly, resistance is symbolized with an R for resistance, and the unit is an ohm. And I think we've talked about that. That's the omega, the Greek letter omega. Okay. So if there's Ohm's law, I equals V over R, sometimes I'll write it with the units instead. And if you write it with units, you have to use the number because units are a measurement. 1 amp equals 1 volt divided by 1 ohm. All right. Did you like that? Did that make sense? I should cut this out and put that in the notes. I will do that. Let's do a sample problem. Here we have a battery. We have current flowing around, and we have a lamp, a light bulb, and that is the resistor in the circuit. So if we know the values of 2 out of 3 of these, we can always find the third. So here we have 12-volt battery, a resistance of 3 ohms in the lamp, and now the question is, what is our current? So I equals V divided by R. What's our voltage? 12 volts. What's our resistance? 3 ohms. What's 12 divided by 3? It's 4. It's okay if you have to plug that into a calculator. So the answer to this would be 4 amps. You have to remember amps, because we're finding an answer in current. Similarly, if you start with a voltage and you have a current, then you can find the resistance. So in this case, we're looking for resistance. I give you the equation, voltage divided by current. 36 volts divided by 4 amps. If you divide 36 by 4, you get 9. So the answer would be 9 ohms. 9 ohms. And then the last problem, where we're going to find voltage. So we know the current is 2 amps. The resistance of the lamp is 7 ohms. So how much voltage does the battery need in order to get 2 amps to go through 7 ohms of resistance? Voltage is current times resistance. So current is 2, resistance is 7. 2 times 7 is 14, and the answer is in volts, 14 volts. Was that okay? Okay, then I'm going to go back in and into the other slide that I've been doing all along. Examples. So here's the first problem. How much current is drawn by a lamp that has a resistance of 100 ohms when a voltage of 50 volts is pushed across it? Voltage is 50 divided by 100 ohms, and you get 1/2 of an amp. Ta-da! It really is that simple. And the only way I make it harder is instead I will give you current and resistance, or I'll give you voltage and current. That's all there is to it. Yeah, that's a nice little way to phrase it. So voltage supplies the push to the electrons, resistance in the material that the electrons are flowing through. The resistance opposes the push, and current results when electrons flow through the material. Do you like that? Is that a nice short summary of it for you? I hope so. Oh, and that is that. So good luck. The homework is short and sweet. And if you have any questions, please don't hesitate to ask. Thank you so much. Good luck. Bye-bye.